All right, today's subject is the boat, blimp, helicopter, train. So, this is a boat, blimp, and it's really interesting because it it, uses a type of body warping to move through the water like a fish. It's each part of the boat is probably bigger than a train caboose. So the idea here is this uses its chassis, the body of the boat, its body, for a flotation device, and it hydroplanes across the water. Very, very nice. So this is this is unweaponized concept, and I made this as big and heavy as it can possibly get. Maximum complexity. I used the biggest heavy parts. It's loaded with a lot of weight. It could probably carry some more weight, but probably would be interesting to see how much weight this can carry. How heavy is this? 6,500 kilograms. That's pretty heavy for a helicopter. So, inflatable blimps at the roof. Deflate, inflate. Oh, wait. Deflate. Well, doesn't really do anything, but pretty much just keep it inflated because it's not going to go anywhere with a blimp alone. But it does significantly reduce the weight. So, what this is doing is maximizing the carrying capacity. What I'm doing with this concept is maximizing the carrying capacity. I want to see how much can it be possible to, how big and heavy can a aircraft become and carry and transport. And this is pretty heavy. It's using a type of body warping. It warps its body, y'all left, y'all right, and that works really good because this thing weighs tons. I think 1,000 kilograms is a ton. So, gosh, I might be way off on the numbers, but so this weighs like something like 7 tons or something. And by using its body like an arrow, it's pretty much like a big arrow. It's almost like flies like an arrow as well. If you ever look at an arrow flying slow motion through the air, it wobbles like that. This is pretty much aerodynamics right here. Very aerodynamic, as aerodynamic as it could possibly get. And by thrust vectoring by accelerating the propeller props at the front, pitch up. I pitch up by accelerating the propeller props at the front. Pitch down, decelerate the propeller props at the front, accelerate the propeller props at the back, pitch down. Pitch up, accelerate at the front, thrust vector up, and then same way with pitch down. And then yaw is a very powerful yaw because you need something like that to displace the inertia. The momentum of this vehicle is massive. It's like trying to stop a train. It's very hard to stop a train. But by chassis warping like that, you're able to use the body as a type of windbreak. So say I'm going like 200 miles per hour. I'm going 200 miles per hour right now. I am yawing right, and then I instantly slow down to 50 miles per hour. Almost instantaneous air brake, because I'm using the body of the chassis to displace the inertia of 7 flying tons. So, very large, powerful rear rudders at the rear. There's this like a turbine jet engine, yaw left, yaw right, rudder at the rear, and then big rockets at the back. So it's like a rocket boat, helicopter. But something like this, a concept like this, using as a boat. Say if this was carrying a ton of cargo, it was too heavy to fly. It's too heavy to fly. It's loaded with a whole bunch of cargo. Say I need to put more weight on this, load it with a bunch of lead or something. What this is doing is hydroplaning across the ocean at 200 miles per hour. And you're able to carry a significant amount of weight. When it's level with the ground like this, hydroplaning, it works good. But by pitching up, it's almost too heavy here. Just a slight 10-degree angle, 5-degree angle. And I am using, I forgot what it's called. It's using its body as a gigantic wing, but it's not a horizontal. It's not a, how would you say, is it vertical or horizontal? I suppose you say traditional wing is horizontal. It's going like a horizontally across the horizon. Okay, but something like this is a linear wing. It's using its entire body as for lift by tilting up at a slight 5-degree angle or something. And then you're able to use the body of this vehicle as a wing. Not to mention, the helicopter rotors. So if I deflate the blimp, this thing is just way too heavy. It is not, the helicopter rotors are not powerful enough to make this thing fly by itself. But if I tilt, I have the gas deflated right now. So the helicopter rotors are lifting 7 tons. But when it's like this at an angle, it is using the body of the vehicle as a wing. It's a linear wing, I suppose you would say. Linear wing concept. And so the blimps are deflated at the top. Wait, no, I just inflated. So the helicopter rotors are lifting 7 tons. Oh, shoot. What happened? I think I just went off the map. Okay. So, if you look at that, his body wobbles like a fish. It's using its body like a type of ornithopter. Its body is acting like a type of ornithopter, being a type of organic type of aviation concept. Robotic. Like kind of like a flying snake, I kind of described it. Kind of like a flying snake. And so as it's flying or swimming through the air, its body is wobbling like a fish. You know, so that might have some interesting aviation concepts, you know. It is like swimming, hydroplaning, wiggling through the water, through the ocean, like a fish would. It's so the hinges here are the train. It's like a train. It's the cabooses are connected by hinges. So hydraulic hinges. So you're able to warp the body. So, and that wiggling effect has a type of ornithopter. Like type of concept. I'm wiggling through the air. I'm vibrating through the air on an arrow. So this is very similar to how arrows fly. When an arrow is shot out of a bow, if you look at the slow motion, it vibrates like that. This is pretty much doing what arrows do. It's very aerodynamic. I mean, this very streamlined, very aerodynamic. Whether or not to use small wings or this truss right here is not very aerodynamic, and it is not providing any lift. But I'm maximizing the lift of the helicopter rotors. So that's why I chose the truss instead of a wing, because I think that this concept here is maximizing the lift from the propeller rotor. It's not that strut. These struts are not aerodynamic. They're aerodynamically neutral. They really suck, but it is maximizing the lift I get from my helicopter props. But small wings would also work as well, but the helicopter strut is really durable and strong. So it's stronger than a wing. It's redundant. I have like 8 engines. Oh, wait, no. I have like 20 rocket engines. 20 rockets. And then big rockets. And then I probably don't need all these engines. I probably could take off some engines. And big rocket engines at the back, too. Probably got too many engines on this thing. But I imagine something like this would be very safe aviation concept, because if anything goes wrong with any part of the vehicle, there are 8, 10 other engines to back it up. It's also amphibious. It's got skis on it. I'm able to ski across the land on something like that as well. Very simple, basic landing gear. Wanted to keep it in but this can maneuver on the ground as well, on the skis. So, kind of made this amphibious. Where was I going with that? So I think that something like this, an aviation concept like this, would be very safe vehicle because it's redundant. Conventional aircraft. Take a very reliable aircraft like the Boeing 747 or something. It's got 2 engines, 2 wings, very simple chassis. But, something like this, it has a whole bunch of engines, a whole bunch of helicopter rotors, gyros, all that stuff. And it's wobbling really crazy. I probably don't need so much wobble. But, it's technically hydroplaning across the ocean. And pretty much it would function the same way it would on land as well. Alright, what else is there? So it's chassis warping. It's a type of ornithopter concept as like a flying snake, I suppose you would say. It's a type of flying snake ornithopter concept. It's a drone concept, a linear drone concept. It's a Chinook helicopter concept. It's a train concept. It's a boat concept. I haven't weaponized this thing yet, but yeah, you can put a whole bunch of guns on here. I maxed out the complexity. I wanted to make something big and heavy, like a train. So I don't have any more space for weapons and stuff. This is just for flying around on the ocean and stuff. For right now. But I probably need to delete 1/4 of this to add weapons. So I'm going to need to make it shorter, but I wanted something big. And it's a blimp concept. It's a boat. It's a blimp, boat, helicopter, ornithopter, drone, linear drone, Chinook. Kind of works as a type of gyrocopter as well. Technically, you don't need to power the helicopter rotors. You can just power the jets and hydroplane across the ocean. So, this thing can take a ton of damage. I've tested it. I mean, it's very durable. Very, very powerful, very strong, very, very interesting aviation concept. I think this is my dream vehicle right here. We gotta make this one day. Everybody, train helicopters. Everybody involved gets a Superfly hot rod. And it's fast. I mean, I think the maximum speed limit for a helicopter is around 150 miles per hour because the propeller rotors are going to start going supersonic. And once you start going supersonic, the propeller rotors start vibrating uncontrollably, and so around, I think, 150 miles per hour is the maximum speed limit for helicopters. I don't know. Aviation, anyways, helicopters might be able to go faster than 150 miles per hour, but typically, most helicopters, you really don't want them to start going over 150. It might be possible to break the sound barrier with something like this. If you break the sound barrier at the front, it might disperse the shock wave and not cause that vibration in the rotors. I don't know. It's going to require some testing and stuff. But a big, gigantic flying boat is totally legit, man. I've got no idea. I don't see why this wouldn't work. So basically how the helicopters work is you're creating low pressure, you're creating a type of low pressure bubble above the aircraft. So low pressure at the top of the aircraft, and the helicopter rotors are pushing the air downwards, creating high pressure. So that's how kind of helicopters work. There are different ways. A gyrocopter works a little bit differently. It's using inertia to create lift. It works a lot like a wing, conventional wing, but so when this thing is flying through the air, the air flowing across the body, there's a possibility. It's really hard to tell how this will function in reality. I need to build a small scale prototype of this concept. RC. I need to make an RC prototype of this concept to see how it works in small scale is what I need to do. But I think that there's a possibility when it's tilted up at a slight 5-degree angle like this or something, you're displacing thousands of square feet of airflow in a downward thrust vector. So there's a possibility that something like this could possibly be more efficient at helicopters transporting large weight. If you want to transport a lot of weight with a helicopter, having something on a big aerodynamic chassis like that would be very, very aerodynamic. And it needs to be weighed down. It's very similar to an aircraft. This thing flies similar to an aircraft. It needs to be very front heavy. So without the power, it's kind of leveled out. I got to constantly push it down, thrust vector down. But without any power, just free falling, using that body, it's a very soft landing. And so it has really good control on the water as well because of that body chassis warping kind of effect. It has a very strong yaw. I gotta do something. It wiggles around too much. I gotta fix that wiggle. It's too much wiggling. But I kind of like it because it adds like a kind of organic fishy. It's swimming like a fish. A fish boat. It's kind of like a mech. A robotic mech. That's what's so interesting about this concept. It's kind of a mech ornithopter, you know. That's what's so cool about it. It's a type of mech ornithopter. Oh, there's so many different. This thing gets so. I've maxed out the complexity on this vehicle. I can't make it any more complex, but I would if I could. I could think of a lot of other really cool stuff to do with this. I was really only halfway done. I haven't even been able to add weapons on this thing yet. I maxed out its complexity. But it could disconnect, and each part of the vehicle is a completely independent functioning vehicle. Each caboose is a functioning caboose. It doesn't need to be connected. Each caboose doesn't need to be connected to the train to fly. Each part of the train can fly. I really would like to test this thing out in small scale and see if this who knows, maybe there might be some kind of wacky air phenomena vortex thing that might mess up the airflow. I don't know. I don't think so. I think this is going to fly as good as it does in the simulator here. That's what I'm thinking about doing next, is building a small-scale prototype of this type of concept. I think it's technically a robot. I think it's technically a type of mech ornithopter robotic concept, because I am using that snake-like, fish-like wiggling. And that could have some interesting aviation characteristics. I am moving through the air like a frequency. This thing is moving through the air like a vibrating frequency, you know? All right. Thanks. Bye-bye.